Hello there, Mr. Sutton here, bringing you the AB Calculus 310 Extra Practice Number 1 solutions on derivatives of exponential functions. For this one, we're trying to find the derivative of x squared times e to the x, so we're going to use the product rule on this one. So u prime v plus uv prime, and let's use the box and ribbon to organize all this. I have factors of x squared and e to the x. Derivatives of those are going to be 2x and, well, e to the x, so that's a nice derivative there. Using the ribbon to put it all back together, I've got 2x e to the x plus x squared e to the x. And let's see if that matches an answer choice. It doesn't, so we're going to have to do something else. Now, some of these answer choices, you'll notice, have some factoring going on. So what could we factor out of this? Well, these terms both have a factor of x and also e to the x. So if I take out an x and an e to the x, that would leave me with 2 plus x inside, and that would match answer choice C. For this problem, we want to find the derivative at x equals 2 for this f of x function here. So let's just go left to right and take some derivatives. This first one, we can use the power rule. This is going to be 3 halves times x minus 1 to the 1 half. And the chain rule applies here, except that we have a derivative of 1 in here, so we don't really have to worry about that tail. For the next term, this is e to the x minus 2 over 2. Well, the derivative of this is going to be e to the something over 2 times the derivative of something. But x minus 2 also has a derivative of 1, so really this is just e to the x minus 2 over 2. Kind of nice. All right, so I know that at some point I'm going to have to plug 2 into all of this. So let me simplify this and get this a little bit more condensed so that's easier to do. So I'm going to have a numerator and a denominator here because these fractions, they both have a denominator of 2, so I can actually combine these. In the numerator, I'm going to have 3 times, I can write this as the square root of x minus 1, plus this e to the x minus 2 term. Denominator is just going to be 2. And so if I plug in 2, I'm plugging 2 into all this stuff here. All right, well, let's see what happens when we do that. So this is 3 times the square root of 1, which is just 3. This is e to the 0 over here, which is just 1. 3 plus 1 gives us 4. So we have 4 over 2, which we can then reduce to 2. So choice C. For this problem, we're told that the graph of y equals e to the tan of x minus 2 crosses the x-axis at one point between 0 and 1. Okay, well, we're going to use the grapher. We're not going to take their word for that. We'll check it out. We want to know the slope of our graph at this point. So I basically need to figure out the x-intercept of this function that happens to fall between 0 and 1, and then I need to take that x value and plug it into the derivative of this thing. So I've got my function, which I'm just going to call f of x equals all this stuff. I'm going to set that equal to 0, and now on the grapher, let me see where this crosses the x-axis. So I've entered my function in my y1, and be careful when you're entering this. Make sure that this minus 2 does not end up in the exponent with the tan of x, because that's going to give you a very different answer. So now to graph this, let me first get my window. And we only want to look between 0 and 1, because that's the interval they said that we're looking for an x-intercept in. So 0 to 1, my x-min and x-max. And let me do zoom 0, zoom fit. And let's see that x-intercept that they were talking about. So this is a very slowly graphing function. There's a lot going on in this. But we definitely have a crossing right here. Let me do second trace and then option 2, 0. Let me click a little bit before and let me press enter a little bit after that x-intercept and enter one more time. And that gives me 0.606 and some change there. So I'm actually going to quit out of my graph now. And I'm going to store that value so that I can use it later on. I'm going to store it as, I don't know, let's use p, alpha p. There we go. All right, so now I can store that. So I'm going to say on my paper here that this crosses at x equals p, which is, again, approximately 0.6061. And now what am I going to do with this? Well, I want the slope of the graph at this x value. So I just have to plug this into the derivative of this function. Now, you could take the derivative by hand and plug it in, but this is a calculator question, so you're allowed to just take the derivative of a function at a specific point. And it's multiple choice, so nobody's looking anyway. But if it were free response, you could just say f prime of p equals, and then it equals whatever the calculator says. So going back to the calculator, let me do math 8 to pull up my derivative. So I've got d over dx, and inside here, let me just put my function, which I stored in y1. So I'll do alpha trace, pull up the y equals menu, and I select y1 from that. And then I want x to equal this p-value that I stored earlier. So I'll do alpha p to get that, and then just press enter. That's going to be 2.961. We'll take their word for it. That's going to be choice D. On this problem, we're given the function a times e to the negative ax, and we're told that a is greater than 0, so a is a constant, which is key on this one. We want to know f prime. Well, we've got the e function. Using our chain rule, we have a times e to the something, which is just going to be a times e to the same something. But we have to use the chain rule now. We have to take the derivative of the inner function, this negative ax. That's just going to be negative a, because again, a is a constant. So we're multiplying by negative a. And if we simplify that, that's going to be negative a squared e to the negative ax, which is going to give us answer choice E. On this problem, we're given the function f of x equals e to the x, and we want ln of f prime of 2. So on this one, I think the easiest way to do it is just to figure out the derivative of this function at 2 and then plug it into the ln function. So start in here and work your way out. Nothing fancy. So f prime in general is just going to be e to the x, because e is its own derivative. And then f prime of 2 is just going to be e to the 2. So again, nothing fancy so far. But now we have to plug f prime of 2 into the ln function. So we're really doing ln of e of 2. And we know that ln and e cancel out. ln is just the thing I have to raise e to get whatever's inside here. Well, what do I have to raise e to get e squared? I have to raise it to a 2. So this is just going to end up being 2 when all is said and done, choice A. On this problem, I'm trying to take the derivative of e to the 1 over x. I'm going to start by rewriting this exponent as e to the x to the negative 1. This is going to be a chain rule that I have to use. So this inner function I'm going to use the power rule on. That negative 1 will make it a little easier to do so. So using my chain rule, I have first the outer derivative. That's going to be e to the something, whose derivative is also e to the something. So e to the x to the negative 1, times the derivative of x to the negative 1. So this is going to be negative x to the negative 2. And turning that into something that looks like one of the answer choices, this whole thing is going to be negative. I have an e to the 1 over x in the numerator. I have an x squared that can come down to the denominator. So that's going to match, let's see, answer choice. We have a negative, we have an x squared down there. Looks like answer choice A. For this problem, f and g are the functions e to the x and x to the 4th. We want to know on what intervals is the rate of change of f greater than the rate of change of g. All right, well, I'm going to start by defining a new function, h of x. That's going to be the difference between f and g, so f of x minus g of x. And the reason I'm doing this is because I'm going to next define another function, h prime of x. That's just going to be f prime of x minus g prime of x. And the reason I'm doing that, if I want to figure out where the rate of change of f prime, is greater than the rate of change of g prime, I basically need to figure out where this thing comes out positive. Because if f prime is bigger than g prime, this will come out positive. Otherwise, it's going to come out negative. All right, so let me define this a little bit more closely, and then we'll be able to put it in our calculator. So f prime, that's the derivative of e to the x, which is also e to the x. G prime is the derivative of x to the 4th. That's going to be 4x cubed that I'm subtracting here. And on my calculator, I'm going to find the x-intercepts for this. So I'm going to find where this equals 0. So let me go ahead and do that now. So here we are in my calculator. I've entered this e to the x minus 4x cubed in my y1. And now I need to figure out a good window to look at this thing on. So looking at my answer choices for a little bit of guidance here, it looks like the earliest critical value that they reference in the answer choices is actually a little bit negative, this negative 0.816. So maybe I want to go as far back as negative 1. And in terms of how far right I want to go, the biggest critical value that's referenced here is this 8.6 and change. So maybe between negative 1 and 9 would be a good window to go in. So let me pick my window as -1 to 9. And we'll see what the function's doing. I can always change my window and regraph it if I need to. Let me do zoom 0 now, zoom fit. And let's see what this looks like. All right, so it's a little bit tricky to see what's going on with the function around here, but definitely we have a crossing over here. So let me go, let's see here. Let me do second trace and find the 0 that's further to the left. So it looks like, let's see, my left bound. Let me go as far back as -1 for my left bound. I'm just going to enter that directly. And for the right bound, let me go out to, I don't know, somewhere around here. There we go. That's past the x-intercept. Press enter one more time. And it looks like that's happening at about 0.8. I think that's a 310. That would match this right here. Now, where else are we crossing? Let me do second trace again and find another 0. And let's see, this is going to happen somewhere between, I don't know, like right here, and I'm just going to enter 9 directly into there. Press enter again, and we have about 7.384. So here's my graph, and we crossed at 0.831 and 7.384. Now I want to figure out where this function is positive, because that's going to tell me where the f prime is bigger than the g prime. So it's going to be positive. It looks like we were positive before we got to 0.831. So that would be from negative infinity to negative 0.831. So that's our first h prime positive interval. And then we were negative between 0.831 and this 7.38. And then after 7.38, we're positive again. So f prime must be bigger than g prime after 7.384. And that's going to go on until infinity because, well, if you look at the answer choices, there's no other options for that. So that's going to then be answer choice B. On this problem, I'm trying to find this limit as h approaches 0. So hopefully you recognize that this is the limit form of a derivative. If you recognize that, all we really have to do is figure out the function that's being differentiated and the value it's being differentiated at. So the function in here, it's whatever the something plus h is being plugged into. In this case, that's the e to the x function. So I'm going to say f of x is e to the x. The derivative in general of e to the x is also e to the x. And here you see that they have a 2 plugged in where the x would normally be. We have a 2 here, a 2 here. So they basically want us to figure out f prime of 2, which is just going to be e to the 2. So that's choice D. On this very abstract problem, they're telling us that f and g are twice differentiable and that g of x equals e to the f of x, which is kind of interesting, and g prime equals h of x times e to the f of x. We want to know what h equals. Okay, well, we have h of x right here. This is the only reference to it. So let's just try to get h of x by itself. So I can do that by dividing both sides of this equation by e to the f of x. So h we can define as g double prime of x over e to the f of x, which is great, but of course that's none of these answer choices. So we're going to have to figure out a way to express this. It looks like all these answer choices are expressed in terms of the f function. So we're going to have to turn this g function into something with f functions. Now g double prime is defined right here. Unfortunately, if you just plug this in, you're going to end up back where you started. So instead, we're going to start with the g of x function that they defined over here, and we're going to take 2 derivatives of that, plug that in here, and then hopefully we can reduce this and get one of these answer choices. All right, so g prime of x, let's start there. That's going to be a chain rule here. We're going to have e to the something, so e to the f of x, times the derivative of the something, which is going to be f prime. So that's g prime, but now we need g double prime to put something in here with. So to get g double prime, I'm going to need to use the product rule, u prime v plus uv prime. So in this case, I'm going to use the box and ribbon here. I've got factors of e to the f of x and also f prime of x. Now the good news is you already took the derivative of e to the f of x earlier, right? That's just this g prime right here. So that's just going to be e to the f of x times f prime of x again. F prime's derivative is f double prime, so also not too bad. Multiplying it all out with the ribbon, g double prime we can say is e to the f of x times f prime of x. times another f prime of x, so I guess I could write f prime of x squared. And then going the other way, we're doing plus e to the f of x times f double prime of x. So we figured out g double prime of x, and it's a whole bunch of gobbledygook here. Let's plug this in now in this fraction up here where we defined h. So I'm going to have all of this stuff over e to the f of x. Now you'll notice that we have an e to the f of x in both of these terms in the numerator. So that means I can divide both of these by the e to the f of x down here, or you could factor out an e to the f of x and cancel. Either way, my terms that are going to be left over when I do that division, that canceling, this first term is just going to be f prime of x squared. This next term, dividing away that e to the f of x, is just going to be plus f double prime of x. Does that match an answer choice? Please say yes. So that's going to be choice D. For this problem, I'm trying to find the slope of the line tangent to x times e to the x at x equals ln of 2. We'll start by taking the derivative of this, and then we'll just basically plug ln of 2 into it. So I need the product rule to take this derivative, u prime v plus uv prime. Let me set up my box and ribbon to help with that. So I have factors of x and e to the x. And then their derivatives are going to be 1 and, e to the x again. That's nice. And before I plug anything back into this expression here, let me just plug ln of 2 into this stuff directly inside the box. So x is just going to be ln of 2. E to the ln of 2, the e and the ln cancel. That leaves us with just 2. 1 is still 1, and this is just 2 again down here. So using the ribbon to multiply that out, I've got 2 plus 2 times ln of 2. And it turns out that's one of the answer choices, basically, choice B.